right? So in round robin, the time quantum is 4 milliseconds, right? So initially P1 will start from 0 to 4. So what happens during that period, P2 and P3 will be in the ready queue, right? So you have to clearly understand what happens inside, right? So from 0 to 4 milliseconds, P2 and P3 will be in the ready queue, right? And then from 4 to 8 milliseconds, process 4 and process 4 will arrive, but when P1 terminates at 4 milliseconds, that will be put back into the ready queue again, right? So that means P1 will be after P3, then P4 and P5 will be arriving to the ready queue, right? So the arrival time is given here is very important in round robin, right? You can see why is it important, right? So P1 burst time is 6 milliseconds. So in the brackets, I have indicated how many milliseconds more required to complete, right? So how much more time needed for completion for P1, right? So you have to clearly understand that, right? So do you understand this step, right? So then P2 is also not completed. So P2 will be put back into the ready queue again, and then we can start P3, right? So this is what happens. Third step, right? P3 will start its execution. So we put back P2 again to the ready queue, right? Then next available in the ready queue is P1, right? So P1 will then execute for another 4 milliseconds, right? So P3 is not completed, so we'll put back P3 again back to the ready queue again, right? Then next step, P4. P4 will start execution, right? So P1 is still not completed. So P1 will be put back to the ready queue again and start P4. P4 will run for another 4 milliseconds, right? So now you can see P4 is also not completed, right? So we need to put back P4 and start P5. Right? So now we can start P5 runs from 20 to 24 milliseconds. P4 burst time is 5 milliseconds. We completed 4. So another 1 millisecond remaining. So we have to put back P5 again to the ready queue. Start P2. Right? So now you can see P2 completes because P2 had only 4 milliseconds remaining. Right? So P2 completes. Right? P2 completes, and therefore no need to put back into the ready queue because P2 is already finished its execution. Now P3 can start for another 4 milliseconds. P3 cannot complete, so we put back P3 again to the ready queue. We can start P1. Right? So P1 has only 2 milliseconds. P1 can also complete. Right? So P1 can complete, then no need to put back P1 again. So we can start P4. P4 will go for another 4 milliseconds, but still P4 is not completed. So we had to put back P4 again and start P5. So P5 has only 1 millisecond, right? P5 can complete, and then there are two processors left. We have to start with P3. So we start P3 for 4 milliseconds. P3 is still not completed, so we put back P3 and start P4. So P4 has only 4 milliseconds to complete, so P4 can complete. And the last remaining process is P3. P3 can complete after 3 milliseconds. Right, so that is how the execution happens in round robin. So round robin is a little bit complex, right? Not like shortest job first or um, first come first serve. It is complex because we have to think about the processes in the ready queue and how the ready queue behaves very clearly. So do you have any questions in round robin? Yeah, the time quantum is already given, right? So normally the operating system will decide the a developer for the operating system can decide on the time quantum, right? So the time quantum will be given to you for the calculation.